everyone, welcome to Math Talk. I'm your host, Brian Heisler. Today we're going to be closing out our series on some popular GED math questions by taking a look at some examples of graphs and charts. So let's get started. We have a question that asks us to match the coordinates below to the points on the graph. And so in order to do that, I want to go and share some information that'll make this a little bit easier and helpful. And there's two things I want to share with you. One of them is that there are different what are called quadrants in a coordinate grid. Starting in the upper right, you have quadrant 1, and moving counterclockwise, you have 2, 3, and 4. And with each of these quadrants, the points that are in those quadrants have specific signs for the x and y coordinates. And that looks like this. So in quadrant 1, both x and y are positive. In 2, x is negative, y is positive. In 3, both x and y are negative. And in 4, your x value is positive, your y value is negative. And so as we look at our different options on the left-hand side, we want to keep those in mind when we're matching up the points that are given to us. So let's take a look at our 4 points and keep the information in mind as we match up the points to their coordinates. So for the first one, negative 5, 1, it looks like I have a negative positive. So if I move along the x-axis, negative 5, and then up 1 along the y, then I get point B. All right? For 3, 6, both of my numbers are positive, x and y, and so I should be in quadrant 1, which would be point C, going to the right 3 and up 6. All right? For the third point, we have 4, negative 2, x is positive, y is negative, which means I go right 4 down 2, that's in quadrant 4, which is A. And in my last point, I have negative 1, negative 4. Both x and y are negative, which means it should be in quadrant 3, which corresponds to point D. All right, let's take another look at an example. So we have a question that asks, which of the following accurately describes the graph? And so we have a bar graph or bar chart that looks like it's talking about or displaying information on number of items sold over the span of Monday through Friday. Okay, and we have different descriptions for the graph. We need to figure out which one accurately describes that graph. So if I go through my descriptions, first one, Monday and Tuesday had the 2 highest sales for the week, and Friday had more sales than Tuesday, Wednesday, and Thursday combined. So Monday and Tuesday had the 2 highest sales for the week. Well, if I look at my different days and the bars that go along with them, I can clearly see that Friday is the biggest bar, which means it had the most sale. So Monday and Tuesday having the 2 highest sales can't be right because Friday should be in there. So that one's out. If I look at my second description, Monday had more sales than Wednesday and Thursday combined, and Friday had more than twice as many sales as Tuesday. Okay, so Monday had more sales than Wednesday and Thursday combined. Well, if I look at Wednesday and Thursday's totals, Wednesday looks like it's about 15, it's in between 10 and 20, and Thursday is about 25, in between 20 and 30. So 15 and 25 is 40, and Monday had 50. So that's more than Wednesday and Thursday combined, so that's true. Friday had more than twice as many sales as Tuesday. Well, Tuesday looks like it had 30, twice as many as that would be 60. So Friday had more than 60, so that looks like it's true as well. So right now that middle description looks like it's probably going to be accurate. Let's take a look at the third one just to be sure. Monday, Tuesday, and Wednesday combined for more sales than Thursday and Friday combined. Okay. Monday, Tuesday, and Wednesday, if we combine those, Monday was 50, Tuesday is 30, and Wednesday is 15. So 50, 30, and 15 adds up to 95. Okay. Thursday and Friday combined, let's see, Thursday is 25 or so. Friday is 80. That's 105. So Monday, Tuesday, Wednesday is 95. Thursday, Friday is 105. Monday, Tuesday, and Wednesday is actually not more than Thursday and Friday combined, so that one's out. Which means, just like we thought, that middle description has to be the accurate description for the graph above. All right, great. Let's take a look at another example. We have a pie graph here, and it says a school has 1,300 students in grades 9 through 12. Use the pie chart below to answer each question. And the question asks, how many more 9th grade students are there than 10th grade students? So in our pie chart, we have a legend at the bottom that says the 9th graders are in blue, 10th in orange, 11th graders in gray, and 12th graders in yellow. So they give us the percentages of students of the total population. We need to figure out the actual number of students so we can figure out how many more 9th graders there are than 10th graders. And so what we can do is, for the 9th graders, we can take our 1,300 students and find 28% of 1,300. And in math, the word of means multiply. So 1,300 times 28%, or 1,300 times 0.28. I recommend using a calculator, and you get 364. Now, the same idea we can apply for the 10th graders in orange, which is 18%. So 1,300 times 18%, or 1,300 times 0.18, calculator gets us 234. Now it's just a matter of taking the difference between those two numbers, and when we do, we get 130 students. So there are 130 more 9th graders than 10th graders. Now this is actually only one approach you can use to this problem. There's another one that I want to show you. We have the same question, and one of the things we can do is we can basically say, well, what is the difference in percentage of 9th graders and 10th graders? And when I look at that, there's 28% of 9th graders, 18% of 10th graders. There's a difference of 10%. There's really 10% more 9th graders than 10th graders. And I can use that because basically that just means I need to figure out what 10% of 1,300 is, and I should get the same answer. So when I do that, 1,300 times 10%, or 0.1, I get, just like before, 130 students is the difference. So there's really two approaches to answering this question. Let's look at one more example with this pie chart. This one says, if 13 students from 11th grade moved up to 12th grade, what would be the new difference between the number of 12th grade students and the 11th grade students? So now we're not looking at percentages, we're looking at the actual number of students moving from 11th to 12th grade. But we still need to look at how many students there are that started in 11th and 12th grade, figure out what happens when we take 13 of them and move them up, and then look at the new difference. So just like in the other example, I have the percentage of 11th and 12th grade students. I'm going to multiply each of those by 1,300. So for 11th grade students, 1,300 times 0.24 to figure out 24%, and then 1,300 times 0.3 to figure out 30% for 12th graders. And this is the number of 11th and 12th graders there currently are. So now it's saying if 13 of those 11th grade students moved up to 12th grade, that means I need to take away 13 of them from 11th grade, and I need to add 13 to 12th grade. So I'm going to go ahead and do that. Subtract 13 from 11th, add 13 to 12th, and I get these new numbers. That means after all that's done, there would be 299 11th graders, 403 12th graders. So the new difference between those two would be 104 students. So I hope this helps as you get to any questions that ask you to plot or to identify points on a coordinate plane, or to analyze and review any kind of charts. I hope everyone is staying safe, and as always, thanks for watching.
If you have any other questions or you need assistance and you live in the Palm Beach County area, visit our website at geds.com to find a location near you and sign up for classes.